Rope tornadoes. Rope tornadoes are among the most common and easily recognized tornado shapes. They are thin, narrow, and snake-like, often twisting as they extend from the cloud to the ground. Rope tornadoes usually appear during the early formation or final weakening stages of a tornado's life cycle. As the storm intensifies or begins to die down, the funnel narrows into this rope-like shape. Despite their smaller appearance, rope tornadoes can still produce dangerous winds. Some rope tornadoes have reached EF2 or even EF3 intensity because they're narrow and sometimes partially obscured by rain or low light. Rope tornadoes can be hard to spot. This makes them especially hazardous for those caught in their path. Their quick formation and erratic movement also add to the risk. Cone tornadoes. Cone tornadoes are what many people imagine when they think of a tornado. They are wider at the top near the cloud base and taper toward the ground, forming a shape similar to an ice cream cone. Cone tornadoes often develop during the mature stage of a tornado's life, when the rotation within the storm has become strong and stable. These tornadoes can range in size and intensity. A cone tornado might be relatively weak, like an EF0, or powerful enough to cause EF3 level damage. Their classic funnel shape makes them easier to identify than rope tornadoes. This visibility is important because it gives storm spotters and meteorologists more time to warn people in the path of the storm. Stovepipe tornadoes. Stovepipe tornadoes have a cylindrical shape with nearly vertical sides that remain consistent from the cloud base down to the ground. They look as though a giant pipe has descended from the sky. This shape often indicates a stronger, steadier inflow of rotating air than what is seen in weaker tornadoes. Stovepipe tornadoes are usually associated with significant storms, often reaching EF2 or higher. Their wide and stable appearance also means they often last longer than the brief rope tornadoes. Because of their strong winds and consistent contact with the ground, stovepipe tornadoes are capable of destroying buildings, overturning vehicles, and leaving a wide trail of damage. Wedge tornadoes. Wedge tornadoes are the largest and most intimidating tornado shape. A wedge tornado is wider than it is tall, often appearing like a massive dark wall sweeping across the landscape. Some wedge tornadoes can grow to more than a mile wide. Wedge tornadoes typically occur in the strongest and most destructive storms, often producing EF4 or EF5 damage. Because of their size, wedge tornadoes can be hard to recognize as tornadoes at first glance, sometimes appearing as a dark, low-hanging cloud. This can make them even more dangerous because people may underestimate their threat until it's too late. The wide path of destruction caused by wedge tornadoes often includes entire neighborhoods or towns. Elephant trunk tornadoes. The elephant trunk tornado is a more dramatic and photogenic shape. It has a long, narrow funnel that widens near the top, resembling an elephant's trunk extending from the sky. Elephant trunk tornadoes typically appear during a tornado's middle stage of development, when the circulation is strong but not yet as broad as a wedge tornado. These tornadoes can vary in strength. Some remain weak and short-lived, while others intensify and grow into wedge tornadoes as they mature. Their narrow lower funnel can sometimes limit the area of severe damage, but the high winds inside the funnel can still cause significant destruction. Multivortex tornadoes. A multivortex tornado doesn't refer to a different outer shape, but to what is happening inside the main funnel. Within the main circulation, there can be two or more smaller rotating columns, called subvortices. These subvortices spin around the center of the larger tornado, like horses on a carousel. Each subvortex can generate extremely high wind speeds, sometimes stronger than the larger funnel itself. This unique structure explains why damage paths from multivortex tornadoes can look patchy, with sections of severe destruction next to relatively untouched areas. Multivortex tornadoes often appear in powerful storms and are especially dangerous because the smaller vortices can strike suddenly and unpredictably. Satellite tornadoes. Satellite tornadoes form as smaller companion funnels that orbit around a larger primary tornado. Satellite tornadoes can sometimes appear weaker, but they still carry strong winds capable of damaging homes, vehicles, and trees. Their rapid and unexpected formation makes them an additional threat during already dangerous tornado events. Storm chasers often find satellite tornadoes particularly challenging because they can quickly shift directions around the main tornado. Landspouts. Landspouts are a type of non-supercell tornado. Unlike most tornadoes, which form from powerful rotating thunderstorms, landspouts develop in rapidly growing cumulus clouds, often without strong rotation at higher levels of the storm. Landspouts usually have a thin, rope-like funnel and often appear translucent or dusty, rather than fully condensed. They are generally weaker than supercell tornadoes, usually in the EF0 to EF1 range. However, landspouts can still be hazardous, especially to people outdoors or in poorly built structures. Their sudden formation makes them harder to forecast than typical tornadoes. Waterspouts. Waterspouts are tornadoes that form over bodies of water, such as oceans, large lakes, or even wide rivers. They often appear as slender, graceful funnels stretching from a dark storm cloud to the water's surface. At the point where the funnel touches the water, it creates a visible spray ring that moves with the tornado. Most waterspouts are weaker than tornadoes that form over land, but tornadic waterspouts linked to severe thunderstorms can be just as powerful. Waterspouts pose a serious risk to boats and can occasionally move onshore, bringing damaging winds to coastal areas. Ghost tornadoes. Ghost tornadoes are one of the most visually deceptive forms of tornadoes. They appear faint, almost invisible, often revealing themselves only through bits of condensation, dust, or debris. This happens when the air in the vortex is dry enough that condensation doesn't fully form. Because the visible funnel is not the tornado itself, but just a condensation cloud, a ghost tornado can still carry destructive winds. This type of tornado highlights the importance of radar and other detection tools because relying solely on visual confirmation can be misleading. Hybrid and transitional shapes. Not all tornadoes maintain one shape throughout their lifetime. Many begin as narrow ropes, widen into cones or wedges as they grow stronger, and then shrink back into ropes as they dissipate. Some tornadoes also have hybrid appearances, such as a cone shape that tapers into a narrow trunk before widening again near the ground. Meteorologists study these transitional shapes closely. Changes in a tornado's structure can signal strengthening or weakening, helping forecasters issue more accurate warnings. Storm chasers often observe these transitions in real time, providing valuable data to scientists. Shape and strength. The shape of a tornado does not always indicate its intensity. A small, narrow rope tornado can sometimes pack EF3 winds, while a large wedge tornado may be weaker than it looks. Tornado shape often reflects the stage of the tornado's life cycle and the conditions in the surrounding atmosphere. Meteorologists use a combination of ground surveys, Doppler radar data, and damage assessments to determine a tornado's true strength. Relying on shape alone can lead to dangerous misjudgments about the threat level. Factors influencing tornado shape. Several factors influence the shape of a tornado. Moisture levels in the atmosphere can affect how visible and condensed the funnel appears. High humidity often produces thick, well-defined funnels, while drier conditions can lead to ghost-like appearances. Wind shear, or changes in wind speed and direction with height, also plays a key role by affecting how the tornado stretches and tilts. The strength of inflow into the storm helps determine whether a tornado remains narrow or broadens into a wedge. Finally, the stage of the tornado's life cycle shapes its appearance. Young and dying tornadoes often appear as ropes, while mature ones are more likely to be cones, stovepipes, or wedges.